honor to close out the session. So what we're going to do is I'm going to introduce both of the panels right here. Very esteemed people, honored to be in the presence of these two. Jerry Kaplan, he's a renowned Silicon Valley veteran. He's founded many companies, two of which became public. He's a fellow at the Center for Legal Informatics at Stanford University Law School. He also teaches social and economic impact of artificial intelligence as a visiting lecturer in Stanford's top-ranked computer science department. His book is Artificial Intelligence, What It Needs to Know, is the most recent. If you haven't read it and you want to get briefed in what is going on, interesting research projects around the universities all over, I highly recommend that. And fun fact, he wrote the software for the first all-digital keyboard synthesizer that was used for the soundtrack of the 1982 movie Tron. So, of course, Tron represents the pinnacle of everything we are talking about now. And then second, I want to introduce Kevin Kelly. Kevin Kelly helped launch Wired Magazine in 1993. He served as executive editor for its first 7 years. Under his tenure, won National Magazine Awards, which are the equivalent of the Oscars for magazines. His new book is Inevitable: Understanding the 12 Technological Forces That Shape Our Future. And very fascinating rundown of how AI is being infected in every day in our households. Again, highly recommend that. Fun fact, he is also a photojournalist, and his photographs have appeared in Life and other national magazines. So I will leave it to, why don't, Kevin, you start it off, and then you give your speech, and then we'll take it from there.
Sound check.
Okay, thank you. It's a wonderful honor to be here. And by the way, I believe that the little bags have a copy of my book, which I signed. All 500 copies. Thank you to our host for providing them to you. I hope you enjoy it. I'm going to give you a really quick glimpse of one part of the book, which was about cognification. And trying to talk about that in this kind of crowd is sort of talking about bringing coals to Newcastle, because most of the people here are probably already. But I think there's 2 points I really want to kind of get to that I want to emphasize that may not be well understood. And they are that, let's see, is it the black one?
Actually, this boy in the corner knows what he's doing. I don't.
Okay. So what does that mean? Which one do I hit? There you go. We have had, obviously, recent advances in the neural nets and the AI. So we had a world Go champion being beat by an AI. So we all understand that there's something happening right now. And I think more importantly was the DeepMind attempt, kind of like a stunt, to teach an AI how to play a computer game. Now, computer AIs have been playing video games for ages, but this one was taught how to learn it. So they didn't actually teach it how to play. They actually taught it how to learn how to play, which is a profound difference. And so this kind of artificial smartness is already present. And as we know, I would say that in a certain sense, your calculator is a genius, smarter than you are in arithmetic. Your GPS is smarter than you are in spatial navigation, and any search engine like Google is much smarter than you are in memory, because it's memorized every word on 6 trillion web pages. It's right there in its head in a certain sense. So we have a sense in which the reason why we want these kinds of intelligences is because they're not like human intelligences. The reason why we want it to drive our cars is because it doesn't drive like we drive. Human drivers, last 12 months, killed 1 million other humans. Humans should not be allowed to drive. Okay, it's very clear. So they aren't being distracted. They aren't worried about whether they left the stove on or whether they should have majored in finance. They're just driving, okay? So that's why we want. In fact, we actually might start to advertise AIs as being conscious-free because they aren't being distracted. That may actually be kind of an advertising idea. So we have a very poor understanding of our own intelligence, as you could hear from some of the talks on it. We have no idea what it is, and it's what we tend to think of it as IQ. Okay, we think of it as kind of like a decibel getting louder, where you start with the IQ of a mouse, you get into the chimp, a little bit more into the kind of a stupid person, then an average person, a genius, and then the AI, and that's totally wrong. As you heard from us, it's much closer that we have this kind of a symphony of different instruments playing different kinds of intelligences in our mind. Our mind is a collection of many different types, and they vary person by person, and they are maybe hundreds, maybe dozens, we don't even know, of logical reasoning, deductive reasoning, spatial reasoning, emotional intelligence. We have a whole basket of different kinds of thinking. And when we get into the animal world, as you heard earlier, sometimes those animals have even the same instruments that we have, and may even exceed us in certain of the modes. In the same way the squirrel being able to remember 10,000 different locations for the nuts, or that amazing chimpanzee doing the number sequence faster than we can. Okay, so when we come to make the machine intelligences, we're going to do the same thing where we're going to engineer them so that in some respects they exceed us in certain of those kinds of intelligences, but in other ones they won't. And that's because there's the universal engineering maxim, which is that you cannot optimize everything. You always have to have a trade-off. One of the great myths about our own intelligence is that we have a general purpose intelligence. We absolutely do not. We have a very, very specific kind of intelligence that was evolved over millions of years for survival on this planet. And when we begin to map all the possible intelligences that are possible, we'll see that our own human intelligence is way off into the corner. It's a very, very narrow, specialized kind of intelligence. So we're going to make these other types of intelligences, and we'll make them more and more complex over time. But the point is that what we're about to do is to make as many different kinds of minds as possible. And some of those kinds of thinking may even be different than the kind of thinking that we do. Just like when we made artificial flying, we didn't do it by flapping wings. We took a barn door and strapped it to a rocket engine. And that's how we did artificial flying. It was a different type of flying. And when we made quadricopters, that was also a completely different kind of flying from biological flying. And we're going to make new kinds of thinking that actually don't occur in biology. And we're going to populate this world of possible intelligences primarily because they're different. You might also think of these as sort of artificial aliens or alien intelligences. And it may be that there are problems that are so difficult in business or science that we actually have to have a two-step process where first these problems are not solved by our own intelligence alone. So first we have to make another kind of intelligence that we work with, and together we solve the problem. Our assumption is that our own kind of intelligence in the universe is sufficient to make other kinds of intelligences. That's an assumption that we have that we're about to find out whether that's really possible. Because you could certainly imagine an animal that could be kind of smart, but not smart enough to make another kind of intelligence. And so our intelligence may be sufficient that we can actually make other types, but we certainly can make other types that can maybe together we can make other types of intelligences. So think differently is actually not a bug, it's the benefit and maybe the chief feature of AI. And the second one I wanted to talk about really quickly is the power of this and what happens when it becomes ubiquitous. We know this is the second industrial revolution. The first one came about because I think of a central invention which I call artificial power. Until that moment, in the agricultural age, everything had to be done with natural power, which is muscle power, animal or human. You couldn't make anything unless you used your own muscles. Artificial power enabled us to make everything in this room, everything that surrounds us. And when you go down a highway, with a flick of your switch, you summon 250 horses, the equivalent at least. Okay? And so we took that power and we distributed it on a grid, the electrification, And that grid was accessible to anybody. You didn't have to generate that artificial power. You could purchase it. You could buy as much as you wanted to. Okay? And you could take something that was done manually, like a water pump, and you could purchase artificial power, and you have the electric pump. So now we're going to do the same thing. Multiply that by 1,000 times. That was the Industrial Revolution. That artificial power that could throw up skyscrapers or factories or cities. Now we're going to take the smart pump, electric pump. We're going to add artificial intelligence. We're going to make the smart pump, multiply that by 1,000 times, and that's the second Industrial Revolution. That's what we're about to do. Okay? We're going to take those 250 horses. We're going to add 250 minds. They're not human minds. They're other kind of minds. And that's the self-driving car. Multiply that. And we're going to deliver that AI as a service, as a commodity, like electricity, like a utility. You'll be able to buy as much IQ as you want, as much AI. It'll be like electricity. What happens when we have that? What could you do if you could buy 1,000 minds and have it work for you 24 hours a day, 7 days a week? What would you do with that? That's what we're on. This brings us to this idea that the next 10,000 startups is very easy. It's a formula that I apparently stole from Barney Pell. I didn't know it. Take X, add AI. That X, if you're going to do a business, everything will have AI. If you want to make it a business, as we said in the previous panel, it has to be a problem that people want to be solved if you want to make a business out of it. But we will add AI to everything. And as James Chimes suggested, if it is a commodity, then the formula should really be take AI and add X. What extra are you going to add to this commodity to make it valuable? So Google is already shifted from being a mobile first to AI. That's where we're going. And it's going to be a conversational interface. When people ask me, what's the future of the internet in 20 years? The vision I have is that it's a conversation that we're having with something all your life. So it's a conversion, it's something that a presence that we're going to converse with. So that's where I think we're going when this becomes ubiquitous. Thank you for your attention.
Sound check. I have, there's sound on my slides. You have it on? Okay. The good people at Oxford University Press approached me and asked me to write a book for their series called What Everyone Needs to Know. And I got interested because I realized there was a gap in the books on artificial intelligence. There are an awful lot of textbooks. If you want to learn how to do machine learning, you might start with a textbook. And there are other kinds of books sort of for the popular media which are mostly saying, oh my God, the robots are coming and you're going to lose your job and they're going to take over and what are we going to do? And there was nothing that really was, I thought, a sober presentation of the field for an intelligent audience that is non-technical. Hopefully many of you are here and just wants to understand basically what is this all about really and what does it mean? What does it mean in a social and an economic context? I probably don't have to work hard to convince you to take a look at my book for the simple reason that it's available for free to everybody here. And that makes me the Oprah Winfrey of AI. You get a free book. You get a free book. So to understand why I was motivated to write this book, let me do 2 short videos. This is the view of artificial intelligence in the general public's imagination. That's what most people think artificial intelligence is. Now here is the reality. A friend of mine said, if you're worried about the Terminator coming to get you, just keep your door closed. So let me quickly just talk about a couple of the ideas I'm going to select out of my book to give you an idea of what you'll learn from it. The first thing, I had a problem when I wrote the book. I had to ask a question. By the way, the book is in an FAQ format. It's question, answer, question, answer. Very easy to read, 40,000 words. You can knock it off in an afternoon, and then you can go to any party and be a big know-it-all. It would be great. So what is the definition of artificial intelligence? The first thing I found is that there is no good definition. All the definitions are horribly flawed. The typical definition is the theory and development of computer systems able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages. Steve Jurvetson is my mentor for talking quickly, so I'm working on that. Now, the problem with this is the typical definition, is it's really flawed. It assumes that emulating humans is a goal of artificial intelligence, which is not really what this is about at all. It assumes that intelligence itself, and this is a major misconception, is objectively quantifiable, that it's some kind of objective thing you can measure. And furthermore, as Kevin pointed out in his slide, that many people think it's linear. Well, you know, IQ is actually not a measure of intelligence at all. It's about developmental competence. You can't give an IQ test to a computer because you can't divide by its age. So AI it's less like mass, so your shoe size, and it's more a perception that we have which may be culturally determined, like beauty. You know, does it mean, intelligence mean the same thing in Karachi and Nairobi, or beauty, I should say, doesn't necessarily mean the same thing in Karachi and Nairobi that it does here in Toronto. The same thing as what does it mean to be intelligent has many different meanings, and I think Kevin really put that very well, so I refer you to his talk. So let me talk about a couple of misconceptions. The first one is that if machines can perform tasks that humans use intelligence to perform, that means that the machines are intelligent. Now, that is not correct. It simply means there are other ways to solve the same kinds of problems. So I picked the same examples that Kevin picked. Let's take the electronic calculator. Back in the 1940s, if you called for a calculator, a human being showed up. And they were a highly skilled and highly trained person who could be extremely accurate, quick at doing sums and things like that. And today, we give away calculators that can do a much better job at as trinkets at trade shows. So the question is, do we think of that calculator as intelligent? I certainly hope not. Another example, moving forward in time, is the win of IBM's Deep Blue in 1997 over Garry Kasparov at the game of chess. Now, if you were around at the time, you would have seen a very similar reaction to what we saw with the recent win at Go, which is a lot of press that said, oh my God, what are we going to do? Now the machines are going to be more intelligent than we are. And there was no shortage of people willing to stand up at conferences just like this, saying, yes, in 5 years we'll solve all these problems. Well, it was 1997, and that obviously did not happen. And the reason that it did not happen is misconception number 2. And that is the mistaken view that what we are doing is building increasingly intelligent machines. The truth is that AI systems is an engineering discipline, and it uses a grab bag of techniques. And those techniques have to be tuned or applied appropriately to each different problem domain. So, going back in history a little bit, that is a Jacquard loom, for those of you who love the history of technology. For some reason, it's disappeared off the slide. That's very odd. That was programmed with programmable punch cards. On the right, chess problem, into that bag, tool bag I was referring to. This was solved mainly using techniques of heuristic search, which was the first wave of artificial intelligence. Here my labels are back. Jeopardy, you know about the Jeopardy win, presumably. That uses a whole bunch of advanced techniques for doing knowledge retrieval. They were basically flexible database query techniques. The driving problem largely is an image processing problem. And the Go problem used pattern recognition and reinforcement learning to solve that particular problem. Now, each of these is not a more advanced version of the last, but if you were a member of the general public, you would come up naturally with the overgeneralization or misconception that what's happening here is we're building ever more intelligent machines, when in fact we're developing new kinds of tools and applying them to different problems very selectively. So, in my book, I talk a lot about the history of artificial intelligence because it's very instructive, going all the way back to the 1956 conference with John McCarthy and I forgot the other guy from MIT. That's what the time change was. Marvin Minsky, thank you very much. The names go first when you get old. This is what I've found out. The last one to go is your own, I think. So for the first 30 or 40 years, what the founders of the field meant by artificial intelligence, what they thought was the basis of human intelligence, was logical inference. They thought that the way you did intelligent actions is you reasoned through the manipulation of symbols in your brain. That was the basis of human intelligence. This is basically about causality, as I can explain in more detail in my book, that A implies B. That was the original formulation of what artificial intelligence was about. Now, the new wave, which I surely don't have to explain to this audience, is loosely called machine learning, and it's a whole collection of different techniques, some statistical, some based on models of the brain, that extract patterns from very large collections of data. And that's more about perception. But from a history of science perspective, it's less about causality than it is about correlation, about associating different kinds of things. So the first question you might ask is, well, what changed? Because even at Stanford, I see an attitude among the students right now. My God, I'm almost out of time. I'm talking too much. What changed is that the machines have improved by a factor of 1 million between 1965 and 2015. The amount of data, I don't have to tell you, has grown from what you could put on a punch card to this enormous torrent of data that runs through the internet. Now, that may sound quantitative, but it's really a qualitative change. Consider the difference in speed between the pace of a snail and the pace of the space shuttle when it's in orbit around the Earth. That is a factor of 500,000. And we're talking about a factor of 1 million here. Can I run 1 minute over? Go for it. Kevin, I apologize. I always talk too much when I do this. So my point here is that artificial intelligence is really not best thought of as intelligence. It's a bad name for the field. It's really a form of automation. I think it's a natural extension of our efforts over the past 100 years to automate tasks that previously required human effort, and in this case, human attention. So I will skip ahead and say that if we had named the field something different, if the founders had called it symbolic programming, we wouldn't have this PR problem with the public. And you might today pick a term, something more like anthropic computing might be more descriptive. And that would be machines that mimic human abilities in form. It also covers biologically inspired computing. Jeff Hinton was talking about his inspiration for his mathematics from the brain. And natural interfaces that we use to talk to our computers. All of that might be best described as anthropic computing. So in conclusion, I don't want you to think I'm anti-AI. I'm not a fan of the concept of superintelligence, but I'm a big fan of the field. I think it's a tremendous advance, and I think that it will have an effect on us, and I'm really not exaggerating, similar to the invention of the wheel in terms of its economic. But this is not magic. And people who promote it as magic are doing a disservice to the field and are misleading the public. It is, however, about automation. Okay, thank you very much.
Okay, yeah, I think maybe we should grab another microphone for this one. Okay, so it's super interesting hearing from both of you, and I think generally you guys are both in agreement of this idea of automation, and it's very interesting because when we were hearing with some of the heavyweights of AI earlier, part of what inspires them to go into this field is to learn about the mysteries of the brain. And it sounds just less mysterious if you're saying, I want to go and make automation better. So what do you feel as like this boom of AI deep learning, how is this contributing as a whole to the the goal of reaching intelligence, what we consider human intelligence, rather than just automation?
So I actually think that one of the unintended benefits of AI is going to be that it is going to be the microscope that allows us to examine intelligence. I think the problem with our own intelligence is that it's very hard to scientifically investigate. We can't do it's very hard to do experiments on ourselves, and that the only way we're going to be able to actually to probe what our own intelligence is through AI, by trying to make these other things. And so it becomes actually the telescope into our minds. And so the only way we can really understand how we think, how our mind is, what intelligence is by trying to create it. And so it's going to, so besides all the other things it's doing, besides the automation, it's actually the chief scientific tool for investigating who we are.
How about this boom right now in automation? How is that helping us with this overarching goal?
I don't think that's necessarily the overarching goal, but it's one of the goals. That's one of the things that happens. It's an unintended benefit. I mean, I think we're lazy, right? We want to automate all the things all the tasks that we want. We want to have cheap food. We want to have cheap housing. And so AI will be the means that will accomplish many of those things. And as a unintended consequence of that, we're also going to change our idea of who we are. So that's not what we're trying to do, but that's what we're going to do.
Right. Sherry, how has your notion of human intelligence changed over the years as following artificial intelligence? How do you view human behavior differently?
Well, one of the things I've come to understand is that human behavior, which is what you're talking about, only bears a certain relationship to human intelligence and is a whole variety of other things. We are creatures, as we saw this morning, that are adapted to survive in certain kinds of circumstances. So when we think about building an artificial person, that's kind of a model or a goal. I think that it may be informative, help us to understand the human better, but we're not actually building an artificial person. Machines are not people, and there's no reason to believe they ever will be people. So when I think about the kind of hypothetical Terminator of the future, I think if it acted exactly like a human, people often say, well, how could you say it's not human or it's not conscious or whatever? The first thing I would ask such a device is, are you hungry? Now, how can a mechanical device answer that question? So when you talk about human behavior,
program it to say, I will get hungry if this happens, if this doesn't happen.
This is one of the problems with the field. We can build demos that are falsely anthropomorphic, and we can fool people. And AI will be used, and is used in chat rooms and other places, to fool you into thinking somebody else thinks something, or something else that's mechanical has empathy for you when it is nothing more than a program. That's a problem, and an ethical problem in the field. But my point is, I don't care how good we are at building an artificial person that is a machine. It is not a person. It will not get hungry. It will not necessarily experience the world in the same way that we do. It won't have subjective experience. And when we ask questions like, can it have free will and can it have consciousness, the truth is, we have no damn idea what that means. So we can't even answer the question in any meaningful way.
Do you find that these philosophical ideas come up every time there is a big boom in AI? It causes people to reevaluate these questions?
Well, even worse than that, I just got back from Korea. Now, here in the U.S., of course, it's very interesting to see the impact of the AlphaGo program at the game of Go over Lee Sedol, who is a very famous person in Korea. But if you went to Korea, what I saw, you'd think we'd see some kind of atom bomb. they are having major investment programs from the government because they're worried that they're behind because of this, and that now somehow the American technology is going to sort of wipe out all of the Korean advances that they've made. So these things are very dangerous because I go there and say, that's wrong. It doesn't matter any more than the fact that a car can run faster than a human being. So,
Right. Well, that's a cultural issue too, because I think in Asian cultures their receptions to robotics, less the Terminator and more the friendly thing you want to interact with. So, going back historically, I want you both to tell us, the boom cycles of AI. What are some of the parallels you've seen in the past, and how are they manifested today? Why don't you start out, Kevin?
Well, I'm a little on the old side, and I've watched this movie for a long time.
That's why we come to hear you.
And I'm sorry to say I've seen this chapter before. I had been to many conferences about the markets for expert systems and investment in expert systems and people talking about applying them to oil exploration, et cetera, et cetera. And so I've encountered many of these cycles of hype and not hype. So for many years, anybody who was doing any work said, I'm building an expert system, I'm putting AI in. But it's not like magic pixie dust that you added. And then as soon as it went out of fashion for investing, nobody was doing AI. But they were doing exactly the same stuff. So my concern here is that we not get this overhyped, that will actually be damaging to the field. And when engineers out of Stanford are being offered millions of dollars, that is not sustainable. They are not delivering $1 million worth of value every year. And so I think you have to be prepared for a collapse in valuations and a focus more on the actual value that's being delivered through applications. There was some very good discussion on the panel. The gentleman from Horowitz, Andreessen Horowitz, I thought he said exactly the right thing. So my advice is don't get overexcited because I don't want to see you all get very disappointed.
So, I think the general rule of thumb is that we tend to overestimate the impact in the short term and underestimate it in the long term. And I think that's happening right now. I think this is something like the Industrial Revolution that's going to take decades to roll out. It'll be going on decades from now, where it's still going on. And so this is, if you think of this as a kind of a multi-decade run, then you don't want it to, it's a marathon. You don't want it to be sprinting necessarily right now. At the same time, this is I think, the most amazing time in history ever to make something, to do something. I think people in 2050 will look back and say, oh my gosh, I wish I was alive and working in 2016 when this was all beginning, when you could have done these amazing things. And so that's also true. Most of the things that people are going to try today are going to fail. So that's also true too. So, but there will be this is a fantastic time to begin because we have all those changes ahead of us. And by the way, from that same perspective of looking back 50 or even 25 years now, they'll say there were no AI experts in 2016. There are a lot of really smart people here, but there are no AI experts compared to what we'll know in 30 years. They'll say, you basically were all wrong, you have no idea, and you didn't even have the internet either. And so from that perspective, I think this is a fantastic time to start. And also from the historical point of view, we've never had better tools to make something, start something. It's never been easier to find an audience. It's never been easier to have the kind of tools to start something. You've never had easier access to money, believe me, than right now. And so this is sort of, in many ways, the best time in the history of the world to start working on AI.
Now, where do you see the role of corporations in this? Because there are tools that are available, but they're always, it's a Google tool, or, you have to use Amazon Web Services to do all this. And so in the future, where do you see corporations, parroting off the previous panel?
I think there's something called network effects in economic terms, which is the winner-take-all effect. The fax effect, they used to call it. Remember the fax machine? So I had one of the first fax machines was like, they used to say, like, the first person to buy a fax machine was an idiot because there was nobody to fax to. Right? Okay, and so that first person became an evangelist for fax machines. You should get a fax machine. You should get a fax machine. Why? Because it made their fax machine more valuable. So I had email early on, and I was a huge promoter of email. Why? Because every person I could get to have an email account made my email more valuable. So you have this thing that the more people who use it, the better it gets. Well, AI is particularly like that in theory, which is that the more people that use an AI, the better it will get. So there's very, very likely that in the AI arena that there will be network effects where there'll be big winners, winner take all. There'll be a few winners in each vertical. There'll be a few winners that are going to dominate because of the network effects. And so I think there are going to be these dominant players in the verticals. The good news is that these temporary monopolies are very temporary. They keep being disrupted. So right now you have these big AIs like Google and Amazon that are relying on the fact that they have these data sets. But if you actually are able to invent a way to have something where you're working with very small data sets, that'll disrupt that. That's a coming disruption in the AI world, is somebody who figures out how to do this with very, very tiny data sets. And though all those big guys will be disrupted. So I think that, for me, I think it's very likely that we'll see some conglomeration of these big dominant players, but I think it's temporary.
Share your thoughts on that. I'd love to hear that.
Well, I think we're going to see a very vibrant ecosystem come in all different levels, verticals, horizontals, et cetera. And that's all you have to do is history always repeats itself in these regards. It's like other types of technology. Somebody earlier today mentioned relational databases. Yeah. Very good model. Started with a single paper, 1972, by T.J. Codd, showing that you could take relational algebra and apply it to the management of data. Completely transformed our view of data. Shortly thereafter, but you could never build something like that. That was what people believed back then, because it was just a thing. Well, IBM and ultimately Oracle built relational databases. They continue to improve them. People built on top of that ecosystem, and it's been a tremendously valuable driving force in the economy and for our productivity. So we're going to see the same kinds of things happen, but you can't at the start point out and say that one's going to succeed and this one's going to fail. There's a lot of serendipity in which tools will become dominant, and little tiny differences, just as in the social networking market, turn out to make a huge difference in adoption, and we're going to see the same thing happen here.
Now, how about when the terminology sort of shifts? Because I think at a certain point where certain techniques of artificial intelligence become so pervasive that we no longer, think of them as AI. We just think of them as data analytics. So where are we with machine learning in this?
Yeah, I mean, other people have said it, and I totally agree that I define AI right now as all the things that we can't do. Because as soon as we can do it, we don't call it AI anymore. We call it machine learning or something, expert systems. So AI moving goalposts that we're all, in 20 years, they'll be talking about, well, someday we'll do AI and we're moving towards it. And as soon as we accomplish anything, it's not AI anymore. And that's just, I don't see an end to that. I don't see any point where we'll agree that that's AI, because we're constantly discovering new things about what it is. If you had,
and is that by speed? Are you quantifying that we're just, humans are unable to do things by speed? Like the amount, I'm thinking about in Jeopardy, Watson was able to beat because it could generate the answers faster than anyone else. Ring.
Right. So I don't know. Do people accept that Watson was AI? Most people probably, you could say yes or no. Certainly 50 years ago it would have been considered AI. Now it's like, well, that's just brute machine learning. That's obvious. That's not really AI. That's, some algorithmic search or whatever. And so I think we have a definitional problem with the very name, as Jerry was trying to say. It's not a really good thing to have called it, but now that it's there, it's always going to be in front of us. We'll always be imagining what it is, and we're always, because we don't know what intelligence is, we're just going to keep redefining it to that which we cannot fake, that which we cannot do is going to be intelligence.
Sure, go ahead.
Let me amplify and perhaps express it slightly differently. The words don't go away, but their meaning shifts. And if you go back and read the original paper, Turing test by Alan Turing, called Computing Machinery and Intelligence, he said in that paper, the question, can machines think, started as too meaningless to deserve serious discussion. How? I believe that within 50 years' time, people will talk about machines as thinking without fear of contradiction. Now, that came to be misinterpreted by all the aficionados of the Turing test, that this test he proposed in there was actually a test for intelligence. Well, what it meant was when computers can perform certain classes of tasks, language will shift enough that we will talk about them as thinking or having intelligence without it having all of those strange, scary, and spooky overtones. And so I think that's what we'll see in the future.
Okay, so we're going to wrap up here, and I'm going to just say, I'm going to ask you, both of you, we both sort of talked about the hype, and, you're saying AI has a PR problem. What would convince you that this is amazing, and it's something that we do, this is unlike any other era in AI? What's it going to be that's going to be that big holy moly moment for you?
I've already been convinced. I have an Amazon Echo. It's like, oh my gosh, that's amazing. I'm amazed, and so I think it has begun. I think it's a little bit more complicated because I think there is creativity in these things already. I think Lee Sedol, the guy who lost, the Go champion, in the move 37 of the third game, he said that was the most amazing creative move in Go ever. And Garry Kasparov, who lost to Deep Blue, he was convinced that we were cheating, that there was a human behind it because there had to be a human. And so we've already passed the test in some ways because he really believed that there was a human there. And so I think it turns out that I think our own creativity is actually not that creative. I mean, it's actually probably more mechanical than we think. And so I think we've already begun. I think this is here. I think this is real. I think this is revolutionary. But I think we're just at the first hour of the first day. So, we shouldn't be celebrating, but we should be honoring the fact that we're on this amazing venture that has already begun.
You got about 10 seconds.
We're over 10 seconds. It's counting.
This is where you need that brute force computing to really get.
T plus 20 here. I think it's all going to be incremental. I don't think we're going to wake up one day and go, oh my God, look at what we've built. But when we're 20 years or 30 years from now, we're going to have flexible robotics applied in all kinds of areas. We're talking about agriculture today. It'll be all over the place, self-driving cars and other applications. I think that in the area of personal assistance, having systems that can adapt more to our individual needs and help us perform for certain kinds of things, I think that in 20 or 30 years, we're just going to say, wow, the world really did change. And that it's a very bright future. It's a very bright future. And if you're familiar with the work of Robert Gordon, one final comment, the economist, he did a bunch of studies and said productivity has slowed down over the past 20 years, and this is the end of productivity growth. The problem is, as an economist, he has to deal with data, and he looks out the back window. It's like driving, looking out the back window. I'm not constrained by needing to get tenure or having to think like an economist. I'm looking out the front window, and I would say that the kinds of technologies that are being discussed here and have brought us together here today are going to be transformative in terms of our wealth, the ease with which we can live, if we solve certain social problems, dealing with transformation of the labor force and its potential negative impacts on income quality.
Easy problems to solve, right? Thank you very much.
You're very welcome.